Hello, kids. This is Mr. Ag, and I'm going to lead you through the math activities for today. It's a little bit weird because there's no page that says here's the math portion of the packet, and the format of the work changes significantly going from writing to math. But a couple things to notice is the tabs over here. It goes from reading to writing and then to math. So you can follow those black tabs. And the math is organized by day. And Miss Nocton and I, we sat down and we looked at it. Well, we didn't sit down together. We Zoomed and talked about it. And we decided that the amount of work that they're asking you to do isn't always a day's worth of work, and sometimes it's more than a day's worth of work. So we paced out the lessons for this week. You've got today, May 12th is Tuesday, May 13th is Wednesday, May 14th is Thursday. We've got 5 days worth of packet work spread out over those 3 days. And of course, you're welcome to use Friday or the weekend. We're not suggesting that you use your weekend time. We're just saying you can manage the work according to your own schedule. And when I say day, I'm talking about the way that they organize it in the packet. This bar on the left here says, okay, this is all the work for day 1. If you get to this bottom spot and you're totally exhausted and you've taken your 60 minutes or one or the other, and you're done, then finish. Put the rest off for tomorrow. But the official assignment for today is day 1, and then day 2, which actually starts right here. And the page numbers go away. There are no page numbers for the math. It's all organized by day. So day 2, and then day 2 ends right here. So that's the official assignment that we have for today, ending with this geometry lesson right here, or this geometry problem right here. And another thing that we noticed, and it's similar to Eureka Math, but even worse, they just don't give you a lot of space to work. So I am going to encourage you to use an additional piece of paper if you can't find the space on the paper. But remember, when we focus on math, we've had many lessons on being neat, organized, and beautiful. And so this, in our work, this is an important part of math, is being organized. And so writing small and neatly is going to be important for you to, especially if you're going to be using this paper to do your work. So what I've done is I've chosen a few of the problems, and I'm going to lead you through them. There's no real theme in the problems. It's kind of like a scattering of different math concepts that we've studied. It is mostly a review, although they are stretching your thinking a little bit and asking you to think about things in different ways from time to time. As usual, if you have any trouble at all, please text or call during the regular school hours, and I'll make myself available to help you out. So we're going to start with this first problem here. I'm going to go through onto the sheet that I made, which is similar to the work that you have to do. We are looking at a little cutout that contains several stamps. And so the first question they ask you is, how many stamps are there? Well, you could just count them, or you could recognize that there are 2 rows of 4, which would be 2 times 4, or 4 columns of 2, which would be 4 times 2. And so for how many stamps, we've got 4 times 2 equals 8, or you could just answer 8. And then it asks the total cost. So you recognize that each stamp actually has a value on it. So on my example, the value is 7 cents per stamp. On their example, you've got 6 cents per stamp. So I've got 8 total stamps at a cost of 7 cents per stamp. That gives me this equation here. 8 times 7. And if you know your facts, you'll know that that's 56 cents. If you need to use a different strategy, you might try dividing this 8 in half, do 7 times 4 and 7 times 4, add 28. You'll end up with 56. You could skip count by 7s, skip count by 8s. You could use repeated addition, although that is more of a second grade strategy, repeated adding. In third grade, we were really focused on learning these facts. So the total cost is going to be 56 cents. And remember, the cent sign goes after the number. If you're using the dollar sign, it goes before the number. And you never use both the dollar sign and the cent sign together in one number. All right, continuing on this, they've got a problem here. Stevie has 4 cards with 8 stamps on each card. Cindy has 8 cards with 4 stamps on each card. Who has more stamps, Stevie or Cindy? You'll notice right away, Stevie's got 4 cards with 8 stamps each. So if you visualize, use the visualization strategy, we've got 4 cards. Each one of those cards has 8 stamps on it. So you've got 8, 8, 8, and 8 on the 4 cards. And Cindy, on the other hand, has 8 cards, and each one has 4 on it. So you've got 4, 4, 4, 4, 4, 4, 4, 4. I think I said 8 of them. And so the way that I organize this, I actually made a different problem that's very, very similar. Hamsini has 3 cards with 4 stamps, and Cameron has 4 cards with 3 stamps. Who has more? Okay, so you have to recognize they're not asking you about this 7 cents anymore. They're only asking you about the number of stamps. So forget about the 7 cents. Hamsini has 3 cards with 4 stamps, and that gives her 12 total stamps. And Cameron has 4 cards that each have 3 stamps, which give 12 total stamps. And so for this situation, we know that the commutative property is at work here. We've got 3 times 4 is the same thing as 4 times 3. So Hamsini's cards equal Cameron's cards. I mean, not cards. Hamsini's stamps equal Cameron's stamps. So 12 equals 12. If they had used different numbers, obviously we wouldn't have a situation where they both have an equal number of stamps, but that's how that one plays out. Okay, I wanted to talk about this one here too. They have a missing digit problem, and we worked with this a little bit last week, but this one's a little bit different. They're asking you to think about the numbers. It says fill in the blanks with digits to make the answer closer to 200 than 300. And if you notice, let's just say we know that this is a 3-digit number and this is a 3-digit number, so we've got a number in the 400s minus a number in the 100s. If we just took 400 minus 100, the difference is 300. They want us to move away from 300 and get the answer closer to 200. So if you think about that, where does it, between 200 and 300, in that range of numbers, where does it change from being closer to 200 to closer to 300? Well, anything all the way up, this is rounding, anything all the way up to 249 is going to be closer to 200. Once you reach that threshold of 250, you're going to be closer to 300. So your goal here is to make your difference 249 or lower. And so you're going to have to figure out a way to make this difference end up to be 249 or lower. If it's 250 or higher, then your difference is going to be closer to 300. I've got an example here just to show the thinking. Make the difference closer to 500 than 600. I've got a number in the 700s minus a number in the 100s. And right off the bat, you can see a number, if we did 700 minus 100, our answer would be 600. Our difference would be 600. So I got to figure out, okay, I need my difference. If I'm shooting for closer to 500, I need my difference to be between 501 and 549. You might ask, why 501? Well, if you think about it, there's never going to be an example where you're locked into a 700 minus a 100 where you can actually get to 500, because you need a difference of 200, and there's just not enough in this second part of the problem here to give you 200 when you're in the 100s. So getting a difference of 500 is actually impossible when you're locked into this scenario. But basically, it works like this. You're going to want the number in the 700s to be low, and you're going to want the number in the 100s to be high, because to get a difference of 500, you want this to be as close to 700 minus 200 as possible. So my first instinct would be to go ahead and make this 700, 700, and then make this as high as you can, 199, so that you get a difference that's near 200, or a second number that's near 200. But I could go, I could really go, if I used 199 here, I could go all the way up to what, 700. If I did 749 minus 199, that would give me 550. And so I don't want to do 749 minus 199. I think the biggest number you can have here is probably going to be 748. 748 minus 199. Now you could use a different combination here. You don't have to do 199. You could do, you would have to go at least to 151 would be the lowest number that you could use here. 151, 700 minus 151 would take you to that 549 number. Because if you use 150, 700 minus 150, you would end up at 550, which is actually closer to 600. That's a lot of talk, and it's a lot of thinking about numbers. I actually kind of like this problem because it gets you kind of stretching your mind about what are the possibilities for achieving this outcome. So, for the 700 number, your number has to be somewhere between 700 and 748 is what we decided. And depending on what you choose here, your number could be anywhere from 151 to, 151 all the way to 199. But just to make it as close to 500 as possible, I'm going to go ahead and do 700 minus 199. You can do any combination as long as your difference is between 501 and 549. Looking through the rest of the assignment, they give you, this is a logic question. There's no adding and subtracting or anything like that. You have to actually put together the clues, the dressing up where Mary likes to dress up her dog. You have to put together the clues. One wears a hat, one wears a coat. She likes to dress up her dogs. One wears a hat, one wears a coat, and one wears a scarf. Their names are Spot, Tag, and Barney. So you got 3 dogs, and they give you some clues about what they're going to wear. Tag loves to wear a scarf. Well, he's probably going to get the scarf. Spot won't wear the coat. So what's left? Okay, so you've got the scarf is probably taken. He won't wear the coat, and so that leaves the hat. And then you're left to figure out what's the last piece of clothing that Barney's going to have. It's just logic. And it asks you to explain your thinking, and then in classic 3rd grade math workbook form, they give you no space to do anything. So I would recommend using a separate piece of paper to answer this question and maybe draw a little diagram.